Okay, Assalamualaikum warahmatullahi wabarakatuh. I'm Luqman Hakim bin Muhammad Jalaluddin. So today we want to explain about experiment 5, which is bending moment. So this my teammates, which is me, Luqman Hakim, Muhammad Syafiq, Hussein Dalma, and Nur Anis Nazrah. Okay, we go through with the introduction. Okay, for introduction, a bending moment is a measure of bending effect that occur when an external force is applied to structural element. A moment is a rotational force that occurs when a force is applied perpendicularly to a point at a given distance. It can be calculated by m is equal to fd. Okay, a bending moment is very important in structural engineers as it can be used to calculate where and how much the maximum force can be applied for a particular beam or structure. Okay, the objective for this experiment is to measure the bending moment of material when subjected to different loads at different distances. Okay, for next, the experiment is carried out with an experimental beam that is separated into two parts and connected by a joint that forms a frictionless hinge with a moment of resistance provided by an end underslung spring balance. Okay, load is induced onto the beam by placing three loads hangers to the parts of the beam. When a load is applied to the beam, it begins to bend. Every time load is changed for new placement, the spring balance is tuned to align both of the beam. Okay, the net force of the load then determined by reading the spring balance. The processes will be repeated for different placements of load hangers on the beam with different loads in this experiment. Okay, at the first there is a vertical force which is P acting on the cantilever beam. Okay, for part A of the beam, the direction of shear force Qx and the direction of bending moment Mx are assumed to be positive. For part B of the beam, the positive direction of Qx and Mx are the opposite. Okay, when the loaded beam is cut through the cross section x prime, the shear force Qx and the bending moment occur. Okay, to achieve vertical equilibrium of part A, the shear force Q in figure 2 is equal to negative RA, whereas for part B, the shear force Q eventually act as shown and has the value of P minus RB.
Now I will talk about the theory and real application for the experiment bending moment. And a bending moment is a measure of bending that effect that can occur when external force or moment is applied to a structural element. This concept is important in structural engineering as can be used to calculate where and how much bending may occur when force are applied. The most common structural element that subject bending moment is the beam, which may bend when loaded at any point along its length. Failure can occur due to bending when tensile stress exerted by a force is equivalent to or greater than the ultimate strength of the element. However, although the mechanisms are different, a beam may fail due to shear force before failure in bending. If beam is not well restrained, a bending force may cause to rotate about pivot point. For the related application, where three types, which is structural engineering field used in building, bridge, and house. And the second is design and technology field, which is the trending wall mounted desk used in this picture. And the lastly is architecture field, in most common creating the building of stair, which is spiral stair, stable stair, and stair tail spanning horizontally. Now I will proceed about the methodology of this experiment. And the apparatus we use is three, which is experimental beam, fixed joint, spring balance, spring gauge, and load hanger P1, P2, and P3. And load we use is 10 Newton, 5 Newton, and 2 Newton. For the first step in procedure for table 1 is the first is the beam was set up as figure 3. The two parts of the beam was aligned by adjusting the spring balance. The initial reading from the spring gauge was taken. 10 Newton weight was applied at P1 and the spring balance was realigned and the reading was taken. The load at P1 was removed and applied at P2. And the spring balance was realigned and the reading was taken. The load at P2 was removed and applied at P3. Then the spring balance was realigned and the reading was taken again. And the step 4 to 9 were repeated by using 20 Newton weight. All the reading was recorded at table 2. For the procedure at table 2, first the beam was aligned as figure 3. The two part of the beam was aligned by adjusting the spring balance. The initial reading from the spring gauge was taken, and after that the phi and weight was applied at P2. The spring balance was realigned and the reading was taken. 10 Newton was applied at the P1 and P3, and the spring balance was realigned and the reading was taken. And lastly, all the reading was recorded at table 2. That's all for me.
Okay, the conclusion for this experiment is the theory was verified such that the shear force and bending moment increases with increasing of load that have been hanged on the beam. Although the results obtained with slightly discrepancy between the experimental and theoretical value of bending moment, the high value of percentage error is probably caused by error that we made during the experiment. Okay, to sum up, we have achieved the objective of this experiment. That's all from us. Thank you.